Hello everyone, welcome to my channel. In this lecture, we will discuss about the extractive distillation. So, we will separate the ethyl acetate from ethanol with the help of Furfural. So, this is a mixture of ethyl acetate and ethanol. We will separate this mixture with the help of Furfural. So, we will add Furfural to separate the ethyl acetate from ethanol with the help of Aspen HYSYS. So this is a paper, research paper. You can search this paper. So we will separate the ethyl acetate from ethanol with the help of Furfural. So first of all, we will go to the Aspen HYSYS. We will add the component. Click on Add ethyl acetate, ethyl acetate, ethyl acetate. Ethyl acetate. This is ethyl acetate. Ethyl acetate. Add ethanol, ethanol, and Furfural. So these are the component. Now click on fluid package, click on add, and we will add a fluid package like the NRTL. So this is the fluid package. Now this is the binary coefficient. Okay. Now we will go to the simulation, and here you can see that the ethyl acetate and ethanol form the minimum boiling point azeotrope mixture. So we will use the extractive distillation to separate the ethyl acetate from ethanol with the help of Aspen HYSYS. So as we see, this is a minimum boiling point mixture, ethyl acetate. So this is ethyl acetate. This is the temperature minimum boiling point mixture, and this is the mole fraction. And at this temperature, 343 about 345.2 Kelvin. They form the minimum boiling point mixture. So this is the conventional method. Here we will use the three column number 1, column number 2, and column number 3. This is the feed which consists of the ethyl acetate and ethanol, and this is the column number 2. In column number 2, the Furfural will be added to this mixture, to this ethanol and ethyl acetate, and it will separate, the Furfural will separate the ethanol and ethyl acetate. It will separate the mixture into two components, ethanol Furfural and ethanol Furfural and ethyl acetate. So there will be some small fraction of Furfural in the top, and major portion of Furfural will come out from the bottom. And here you can see there is about 5 or 100% Furfural will be obtained at the bottom. You can recycle this Furfural to get more purity of this Furfural. So here this is column 1, column number 2, and column number 3. All columns are operating, the condenser and reboiler are operating at 1 atmospheric pressure, and this is the feed. The feed consists of saturated liquid, and it is 25% ethyl acetate and 75% ethanol, and this is about 180 atmospheric pressure. So ethyl acetate and ethanol. So we will go to the model fillet. select and drag the distillation column number 1. This is column number 2. Drag and drop. Select distillation column, drag and drop. This is distillation column number 3. Okay. Now double click on column number 1, and here there are 10 number of stages. So we are assuming that there are 10 number of stages, and this is the feed, which is ethyl-acetate and ethanol. And there is a total condenser, and the condenser duty is QC1. Sorry. Oh, okay. QC1. Condenser duty and the reboiler duty per distillation column number 1 is QR1. And this is the overhead product liquid. So this is the top product of distillation column 1, bottom product of distillation column number 1. This is feed. It is entering at stage number 5 to the distillation column, and this is the total condenser. Okay, click on next, and this is a 1 through reboiler. Okay, the condenser and reboiler pressure is suppose 101 kilopascal, and the reboiler pressure is 101 kilopascal. Okay, suppose the reboiler pressure is 102 kilopascal. I am assuming this value. So the temperature, we don't know the temperature, so we will skip. Click on next, and the reflex ratio. So suppose the reflex ratio is 1.8. Now click on done. So this is unconverged. Now close this one. Okay, close this one. This go to the feed. This distillation column 1 feed. So the feed here you can see the feed molar flow rate is 300 kilomole per hour and 25% ethyl acetate. So go to the composition, 25% ethyl acetate, 25% ethyl acetate and 75% ethanol, and there is no furfural in the feed. Click on OK. Now it shows unknown temperature, so go to the conditions of the feed, and the feed is suppose it is at 25 degrees C and 1 atmosphere pressure, 101 or 102 kilopascal. The molar flow rate of the feed is 300 kilogram mole per hour, and click on OK. Now this is the feed to the distillation column. Now double click on this column. Okay, close this one, and here you can see that the distillate of distillation column number 1 is entering to distillation column number 2. So, and here you can see a fresh furfural is also entering to the second distillation column. So we will add a fresh furfural to the second distillation column. So we will go to the flow sheet mode and modify. Click on model and stream, and add fresh furfural to the second distillation column. So this is stream number 1. Double click on this one and rename. This is the fresh furfural which are entering to distillation column number 2. As temperature, we are assuming that it is entering at 25 degrees C and 101 kilopascal, and its molar flow rate is suppose 100 kilomole per hour, and suppose it is a favor furfural 1. Okay, click on OK. Close this one. Okay, this is the furfural stream which will be entered to this distillation column number 2. This is distillation column 2, this is distillation column 3, and this is distillation column number 1. And these are this whole process is extractive distillation process to separate the ethyl acetate from the ethanol. Okay, now double click on this column, and the top of the distillation column number 1 is this is the furfural. It will be entering to the second column, and the top of the distillation column will be also entering to the distillation column number 2. Suppose there are 12 number of stages, and the condenser energy of the column number 2 is QC2, and the reboiler duty of the column number 2 is QR2, and this is a total condenser. The bottom product of distillation column number 2 is, suppose it is B2, and this is the top product of distillation column, which is T2. Okay, now the feed is entering to stage number at stage number 6. Purfural is entering at stage number 6. Suppose the purfural is entering at stage number 5 or at stage number 4, suppose. Okay, now click on next. Once through reboiler is okay, click on next, and the condenser and reboiler pressure are suppose 101 kilopascal and 102 for the reboiler. Click on next, click on next, and the reflex ratio. So suppose the reflex ratio is 2 for second distillation column, and it is unconverged, so we will converge it later. Okay, now now here you can see that the bottom of the distillation column number 2 is entering to distillation column number 3, and some are reflexing, so this bottom will entering to distillation column number 3. The bottom of distillation column number 2 is entering to distillation column number 3, so this is B2. It is entering to distillation column number 3. It is a total condenser. The top product is B3 and the bottom product is B3. And there are, suppose there are 14 number of stages. I'm assuming these stages. So you can use some other numbering of stages, some other information according to your problem. Now this is the condenser QC3 column 3, and the reboiler of the column number 3 is QR3, and this is total condenser. Okay, click on next. Once the reboiler is okay, click on next. The condenser pressure is 101, and the reboiler pressure is again, suppose it is 102, and click on next. This optional, click on next. The reflex ratio is suppose 2.2, and click on done. Okay, it is also unconverged, so we will close this one. And here you can see, if you double click on distillation column number 1, it shows some problem, the convergence problem. So here we will go to the monitor, and here you will see the degree of freedom is 0, but we have not specified the distillate or reflex rate, so only the reflex rate we specify. So we will uncheck this one, uncheck this one. I will suppose we will suppose add specification. Click on this one, and click on column component fraction. Click on add specification. So here you can see that there is 55% ethanol is obtained at the top of distillation column number 1. So suppose the 55%, 55% ethanol, 55% ethanol. So click on add specification, column component fraction. Oh, I will, okay. Click on this one. Here you can see a distillate. This is the condenser. 55% ethanol is obtaining at the condenser of distillation column number 1. So 55% ethanol liquid form, and it is obtaining at the condenser ethanol. Okay, this is ethanol. Okay, so now click on run. So it is converged. Now close this one, and here click on distillation column number 2. At distillation column number 2, it is also show convergence problem. So we will go to the monitor, and here the reflex ratio is okay, but we have no information about the distillate. But we have information that the 87% purfural is obtaining at the bottom of distillation column number 2, 87.90. So we will assume 87% purfural at the bottom. So click on add specification, and click on column component fraction, click on add specification, and it is obtaining at the reboiler of the second distillation column. Click on reboiler, and 87% purfural, suppose 87% purfural is obtaining at the bottom of the distillation column number 2. Click on this one, and this is okay. Click on run. So the column P purfural is entering below the stage pressure. Click on OK. Column T is entering tower below. Okay. Okay. Now close this one. Okay. Now click on distillation column number 3, and here it also show the convergence problem. So we will go to the monitor, and here we will assume that the we will suppose the Furfural at the click on add specification, and suppose the Furfural fraction at the bottom of distillation column number 3 is 99%. So click on add specification, okay, this is column component fraction. Click on add specification, and the Furfural stage is the reboiler, okay, and this is 99% Furfural, okay, Furfural, okay. Click on run. So it is converging, but it will take some time, so we will stop the simulation, and here we will the bottom product rate. So here you can see that this stream, the molar fluid of the stream is 114.9 kilomole. So I will double click on distillation column number 3, and I will assume that the bottom product rate is suppose 50 kilomole per hour. I'm assuming this value. So now this is converge. Now close this one, and here you can see that double click, if we double click on this stream and go to the composition, so here 100% purple is obtaining at the bottom of this column, and here you can see that how much purple and ethanol. So here you can see purple 76% and 22% is ethyl-acetate, and here you can see majority of ethanol is obtained at distillation column number 2, at the top of distillation column number 2, and at the bottom of distillation column number 2 you can see that majority of ethanol is obtained at the bottom of distillation column number 2. So in this way we can separate the ethyl-acetate from ethanol with the help of Furfural in extractive distillation column. So here you can also obtain the condenser duty. Suppose the power of condenser is 4569 kilowatt. The reboiler duty for the column 1 is 5241 kilowatt, and the power of condenser for column number 2 is 4489 kilowatt, and the reboiler power for column 2 is 5073 kilowatt. The condenser power for column 3 is 2754, and this is the reboiler duty. The reboiler power for the column number 3 is 2787. So this is the extractive distillation problem, that how can we separate an azeotrope mixture, minimum boiling point azeotrope mixture of ethyl-acetate and ethanol with the help of Furfural and extractive distillation column. Thank you very much for your attention. If you are new to the channel, please like and subscribe.